Now we have to going to start the numerical based on conservation of energy. Now let's start the solved examples. First example, we have a ball of mass 50 gram is thrown vertically upwards with an initial velocity of 20 meter per second. Calculate the initial kinetic energy imparted to the ball. Next, the maximum height reached if air friction is neglected. Third, we have to calculate the maximum height reached if 40% of the initial energy is lost against the friction. Take G value as 10 meter per second square. Now carefully see the question. A ball of mass 50 gram. A ball having mass 50 gram is thrown vertically upward with an initial velocity of 20 meter per second. We have to calculate the initial kinetic energy imparted to the ball. So initial kinetic energy we have half mv square, but here v is actually a initial velocity which is u square, which is given as 20. Now mass is given in gram, so let's convert it into SI unit, which is kilogram. So divided by 1000, we got mass as 1 by 20 kilogram. So mass value I got in kilogram as 1 by 20 kilogram. Now let's calculate the kinetic energy. Kinetic energy we have initial kinetic energy half, mass value is given as 1 by 20, and velocity square. Velocity how much? 20 square. So 20 square. So just write it as 20 into 20. So here 20 and 20 cancel out. 2 with 10, 20, that is 10 joule. It means that the initial kinetic energy imparted to the ball we have 10 joule. Now we have to see the maximum height reached if air friction is neglected. It means that when you give the velocity to the ball starts moving in the upward direction and attains some height. So before coming to rest, it attains some height. So we have to calculate the maximum height when air friction is zero or air friction is neglected. It means that due to the conservation of energy, the whole kinetic energy which is given at the starting point is converted into a potential energy. So potential energy and kinetic energy both are equal according to the conservation of energy. So potential energy formula is mgh, and kinetic energy we have already calculated at this point in the previous part, that is 10 joule. Okay, kinetic energy we have 10 joule. Mass we have calculated in kilogram, 1 by 20 kilogram, g value is 10, and h we have to calculate. So from here h value we got it as 20 meter. It means that the maximum height reached when air friction is neglected or air friction is not there, then maximum height reaches 20 meter. Next we have the maximum height reached if 40% of the initial energy is lost against the air friction. What is the meaning of this? Carefully see. For example, we have given some energy. So some energy is lost in the air friction. How much this energy? This energy is 40%. Means 40% of the initial kinetic energy is lost in the air friction. So 40% means 40 into 1 by 100 of multiply kinetic energy. How much initial kinetic energy we have? We have calculated 10 joule. So from here we got 4 joule energy is lost. If 4 joule energy is lost in the air friction, how much left? So left energy we have initial kinetic energy minus lost part. Initial kinetic energy we have 10 joule, and how much lost? 4 joule is lost. It means how much energy is left, still left. So kinetic energy left after the lost part is 6 joule. It means that this new kinetic energy now converted into potential energy to reach some height. Okay, so this new kinetic energy is converted into potential energy. How much is new kinetic energy? 6. Potential energy new we have mgh. Mass value we have 6. Mass value we have 1 by 20, g value we have 10, and h we have to calculate. So from here we got h as 12 meter. It means that the maximum height reached if 40% of the initial energy is lost against the air friction, that is 12 meter. Clear? Next question we have, a ball of mass 20 gram falls from a height of 10 meter and after striking the ground it rebounds from the ground to a height of 8 meter. We have to calculate the kinetic energy of ball just before striking the ground. Next we have to calculate loss in kinetic energy of ball on striking the ground. And what happened to the loss in kinetic energy in second part? Take g value as 10 meter per second square and neglect the air friction. Now carefully see the question. A ball of mass 20 gram, mass is given as 20 gram, is fall from a height of 10 meter from the ground. Okay, after striking on the ground it rebounds to a height of 8 meter. Okay, now we have to calculate the kinetic energy of ball just before striking the ground. Just before striking the ground, the whole potential energy is converted into kinetic energy. So just before striking the ground, whole potential energy is converted into kinetic energy. Potential energy we have mgh, and kinetic energy we have to calculate. Mass we have 20 gram, so let's convert it into kilogram, divided by 1000, g value is 10 and h is 10 meter. Before striking the ground, initial height we will take as 10 meter. So kinetic energy in this case we got it as 2 joule. Kinetic energy we got it as 2 joule. So here initial kinetic energy we got it as 2 joule. Clear? Now we have to see a ball again. Now carefully see. Now we have to find the loss in the kinetic energy of ball on striking the ground. So when ball which is at some height, a 10 meter, after rebounds it goes to a height of 8 meter. Okay, now we have to calculate loss in kinetic energy. Means we have final kinetic energy minus initial kinetic energy. Okay, so here if I'm talking about loss, so there is some loss in energy, so we will always subtract higher value minus lower value. So higher value in this case we have initial kinetic energy, not final, and final kinetic energy. Because initial kinetic energy is more and final kinetic energy is less, we are calculating loss, so we will subtract initial minus final. Initial we have already calculated, that is 2 joule. Now we have to calculate final kinetic energy. So if we are talking about final kinetic energy, after striking the ground the ball attains a height of 8 meter. It means this final kinetic energy is equals to final potential energy. Final potential energy we have mgh and it is equals to final kinetic energy. So mass value we given it as 20 gram divided by 1000, g value is 10 and h value is 8 meter. So now calculate here. So you will got final kinetic energy as 1.6 joule. So put the values. Initial kinetic energies we have 2 joule and final kinetic energy we have 1.6. So here you will got it as 0.4 joule. It means loss in kinetic energy we have 0.4 joule. Now the question arises, why there is loss in this energy? Means if loss is there 0.4 joule, where this energy actually goes? So this energy is basically when it strike with the ground, when the ball strike with the ground, some form of heat is produced and some form of sound is produced. So this 0.4 joule is appeared as a heat or sound energy, or lost it as a heat or sound energy. Clear? Next we have a simple pendulum while oscillating rises to a maximum vertical height of 5 cm from its rest position. When it reaches to its extreme position on one side, if mass of the bob of simple pendulum is 500 gram and g value is given as 10 meter per second square, Find the total energy of simple pendulum at any instant while oscillating and velocity of bob at its mean position. State the assumption made in your calculation. Now carefully see, first part we have a simple pendulum while oscillating raises to a maximum vertical height of 5 centimeter. A pendulum is there which on oscillating goes to the maximum height, and maximum height from the mean position is given as 5 centimeter from the rest position. Okay, on the another extreme position, if mass of the bob is given as 500 gram, so convert it into kilogram, just divide it by 1000. So here we got it as 1 by 2 kilogram. Now G value is given, we have to calculate the total energy of simple pendulum at any instant. So if they are talking about at any instant, we will calculate at this instant A at the extreme position. So here we have a potential energy. So potential energy at A we have mgh. Mass value is given as 1 by 2, G value 10, and height is given in the centimeter, 5 centimeter. Let's convert it into meter. So here we got that is 1 by 4 joule, and when you convert it into decimal, so you will got it as 0.25 joule. It means that the total energy of pendulum at any instant while oscillating is 0.25 joule. Next we have to calculate the velocity of bob at its mean position. Means here we have calculated the energy as potential energy as 0.25 joule. Now we have to calculate at mean position what is velocity, because at mean position kinetic energy is there. So we know that according to the conservation of energy. So here assumption I am also telling you what assumption you will write according to the conservation of energy, and assumption is that the air friction is neglected. So whole potential energy is converted into kinetic energy. This is only possible when we neglect air friction. So here assumption is clear that we are neglecting air friction. So potential energy we have already calculated as 0.25 joule. Kinetic energy at this point we have half mv square. Here we have to calculate the value of velocity. So here half mass value we have already calculated, that is 1 by 2 kilogram. So put the value 1 by 2 v square as it is. So here 0.25 you can write it as 25 by 100 also. Cancel it out, you will get 1 by 4. So here on this side, left side, 1 by 4 v square is equals to 1 by 4, 4 going on the right side. So v square we got it as 4 by 4. So 1. So we have under root 1. So under root 1 we have 1 meter per second. Why 1 meter per second? Because we have to calculate velocity and whole system is going in the SI. So here velocity we got it as 1 meter per second. Clear? Next we are going to start the numerical based on conservation of energy. Now we have to see the unsolved numericals. First we have a ball of mass 0.2 kg is thrown vertically upward with an initial velocity of 20 meter per second. Calculate the maximum potential energy it gains as it goes up. So for example, a ball is thrown vertically upward with an initial velocity of 20 meter per second and mass of ball is given as 0.2 kg. So here we have to calculate the maximum potential energy gained by this ball. So according to the conservation of energy, kinetic energy at the minimum point at the ground level is equals to the potential energy. So here if I am talking about, this is because here we have taken the assumption that is air friction is neglected. Okay. So now kinetic energy is half mv square and potential energy we have to calculate. Half mass value is given as 0.2 kg and velocity is 20 square. So here if you will solve, so this 2 is cancelled with 0.1. 0.1 means 1 by 10. 20 square means 20 into 20. So here you got 40 joule. It means that the kinetic energy at this point is 40 joule, which is completely converted into potential energy at this point. This is also again a 40 joule. So here if I am talking about potential energy gain, so this answer is 40 joule. Clear? Next we have a stone of mass 500 gram is thrown vertically upward with a velocity of 15 meter per second. Calculate the potential energy at the greatest height, kinetic energy on reaching the ground, and the total energy at its halfway. Now the question is same, carefully see. A ball is thrown vertically upward and with an initial velocity of 15 meter per second, and the mass is given as 500 gram. 500 gram means, let's convert it into kilogram, just divide it by 1000. So here we got it as 1 by 2 kilogram. Now they are saying calculate the potential energy at the greatest height. Potential energy at greatest height, carefully see. Kinetic energy at this point is completely converted into potential energy at this point when air friction is 0. It means that kinetic energy is equals to potential energy. Kinetic energy at the lowest point we have half mv square. Here velocity we have to take initial velocity, which is 15 meter per second. So this is equals to potential energy at the greatest height. So potential energy we got it as half, mass value we have 1 by 2, and velocity we have 15 square. So this become 1 by 4 into 15 into 15. So when you solve it, potential energy value you will got it as 56.25 joule. Okay. So the potential energy at the greatest height we got it as 56.25 joule. Now next we have the kinetic energy on reaching the ground. Carefully see, when the ball again moves in the downward direction, whole potential energy converted into again kinetic energy. So at the lowest point before touching the ground, complete potential energy is converted into kinetic energy. So at the lowest point, kinetic energy we have same according to the conservation of energy, that is 56.25 joule. Now we have to calculate the total energy at its halfway. According to the conservation of energy, at each and every point energy remain conserved, means each and every point energy value remain constant. So at the midway we have same energy, same value of energy which we have here at the maximum and here at the maximum kinetic. Here we have in the form of potential, here we have in the form of kinetic. So here is a mixture of kinetic and potential, but total energy remains same, that is 56.25 joule. Clear? Next we have a metal ball of mass 2 kg is allowed to fall freely from rest at a height of 5 meter above the ground, taking g value as 10 meter per second square. Calculate the potential energy possessed by the ball when it is initially at rest. Second, we have to calculate the kinetic energy of ball just before it hits the ground. Last, we have to calculate what happens to the mechanical energy after the ball hits the ground and come to rest. Now carefully see the question. A metal ball whose mass is given as 2 kg is allowed to fall freely from a rest at a height of 5 meter from the ground or above the ground. Taking g value as 10, we have to calculate potential energy possessed by a ball when it is initially at rest. Initially at rest we have here a ball is at some height, so this ball possesses potential energy which is mgh. Okay, mass value we have 2 kg, g value we have 10 meter per second square given, h value is given as 5 meter. So when you will multiply, you will get 100 joule. So potential energy you will got it as 100 joule. Now next we have to calculate the kinetic energy of the ball just before it hits the ground. So ball which is above 5 meter from the ground, when this ball is released and hits the ground, so now carefully see, this whole potential energy is converted into kinetic energy. This is called conservation of energy. This is only happens when air friction is 0. So here assumption we have to take that we are neglecting the air friction. So whole potential energy we converted into kinetic energy. Potential energy we have already calculated in the previous part, that is 100 joule. Just substitute the value, and kinetic energy we as it is. So here we got kinetic energy as 100 joule. So the kinetic energy of ball just before it hits the ground, that is 100 joule. Now next part we have what happens to the mechanical energy after the ball hits the ground and come to rest. So when the ball hits the ground, this whole potential and kinetic, some form of energy is stored in the ball. So this whole energy is wasted, or whole energy is transformed from potential and kinetic, that is whole mechanical energy is converted into heat and sound energy. So what happens to the mechanical energy? Mechanical energy gets converted into heat and sound energy. Clear? Next question we have, the diagram given below shows a sky jump. A skier weight 60 kgf stands at point A at the top of a sky jump. He moves from point A and takes off from the point B. Now we have to calculate the change in the gravitational potential energy of the skier between A and B. If 75% of the energy in part A, which we have calculated, become kinetic energy at point B, calculate the speed at which the skier arrive at B. Now carefully see the question. Here at A point, skier jump stands. Now from A point, he moves and takes off from the point B. We have to calculate the velocity at point B and change in gravitational potential energy. So now let's calculate. The diagram given below, here we have to calculate the change in the gravitational potential energy between A and B. So change, if I am talking about delta P you can represent with capital P, potential energy as potential energy at point A minus potential energy at point B. So potential energy at point A we have mg height at point A minus mg height at point B. So here they have given the weight is 60 kgf. It means they have given as mass as 60 kg. So weight, if I am talking about, W is equals to mg. So we have to calculate mg, that is 60 into g. G value we will take as 10. Okay, so G value we will take it as 10. So here 60 into 10, height we have 75, minus 60 into 10, height we have 15. So when you will solve, you will get 36000 joule. Now let's convert it into a standard form. So here you will write 36 into 10 raised to power 3 joule. So now here you need a decimal, divide by 10, multiply with 10. So here you will got 3.6 into 10 raised to power 4 joule. So this is the change in the gravitational potential energy between point A and B. Next we have to see, if 75% of the energy in part A become kinetic energy at B, calculate the speed at which the skier arrives at B. Now carefully see, they are saying if 75% of the energy, 0.75 means 75% of the energy which we have calculated in the first part, which is 3.6 into 10 raised to power 4 joule, is converted into kinetic energy at point B. So we have to calculate the velocity at point B. So now here if you will solve 75 by 100, so 36 by 10 and 10 raised to power 4. Kinetic energy at point B we have half mvb square. Okay, so from here 1 2 3 1 2 3. This 2 is multiply on that side, 75 into 36 into 10 into 2. Mass value we given as 60 and Vb square. Now 60 just divide it with 60, 75, 30, 10, 2 divided by 60 VB square, cancel it out. So here you will got 150 into 6 VB square here we have. So here it become 900. So VB square we have 900. So VB we got it as velocity at point V we have under root 900 which is 30. So velocity at point B we got it as 30 meter per second. Clear? Next we have a hydroelectric power station takes its water from a lake whose water level is at a height of 50 meter above the turbine. Assuming the overall efficiency is 40%, calculate the mass of water which must flow through the turbine in each second to produce a power output of 1 megawatt. Take G value as 10 meter per second square. For example, a lake is there which is 50 meter above the level of a turbine and falls on the turbine. Okay, so now the overall efficiency of system is given as 40% and power output is given as 1 megawatt. Power output 1 megawatt, let's convert it into kilowatt. So here it becomes, in watt SI unit, this become 10 raised to power 6 watt. Now we have used the formula of efficiency as power output by power input. Here power output is 10 raised to power 6, power input we have to calculate, and efficiency is given as 40%. 40% means 0.4. So here power input after getting cross multiply we got 10 raised to power 6 divided by 0.4 and this become 2.5 into 10 raised to power 6 watt. But this is the power input which is given by the water. We have to calculate the energy in order to calculate the mass. So energy we have power into time. Power input we have calculated, that is 2.5 into 10 raised to power 6 watt into time. They are talking about each second. It means time is given as 1 second. So here energy we got it as 2.5 into 10 raised to power 6 joule. Now we have to calculate the mass. So here energy we have already calculated as 2.5 into 10 raised to power 6 joule. And this energy is actually stored in the water in the form of potential energy. So potential energy we have 2.5 into 10 raised to power 6 joule. Now we have to calculate what? We have to calculate mass. We know that potential energy formula we have mgh. Potential energy is 2.5 into 10 raised to power 6. Mass value we have to calculate, G value is 10 and H value is height 50 meter. So mass here we have calculated as 2.5 into 10 raised to power 6 divided by 10 into 50. So here we got it as 25 by 10 into 10 into 50 and 10 raised to power 6 means 6 zeros. Okay. So now we have to just cancel it out. So here you got 5 into 1000 as mass is equals to 5000 kg. It means that the water flows 5000 kg in 1 second. They are actually asking about the mass flow rate. So mass we got it as 5000 kg when for each second. Clear? Next we have the bob of a simple pendulum is imparted a velocity of 5 meter per second when it is at its mean position. To what maximum vertical height will it rise on reaching at its extreme position if 60% of energy is lost in overcoming the friction of air? Now carefully see a bob of simple pendulum. Here it is having mass m. So initially this bob is at mean position. We have given velocity to this bob which is 5 meter per second, and after losing the 60% energy the bob gets some height. Okay, we have to calculate the value of this height. Now here carefully see, initially the bob we have given some velocity, so the initial energy this bob will get, that is a form of kinetic energy which is half mv square. So half mass value we have m Here mass is not given, so we will take value as m only. Velocity we have 5 square. So 5 square we have 25 by 2 m. Okay. So this is the initial energy stored or initial energy is there in the pendulum or energy given to the pendulum. Now this pendulum is going to some height, raises to height, but condition is that 60% energy is lost. 60% energy is lost. Total we have 100% energy. So out of that only left part we have 40%. It means that energy left we have 40% of energy, which is initial energy, 25 by 2 m. So just here cancel it out, calculate some things. Okay, so here we got it as 5 m. So the energy left in this pendulum we got it as 5 m. M is a mass. Now this whole energy is converted into potential energy. So according to conservation of energy, kinetic energy at mean position is equals to potential energy at extreme position. Kinetic energy we have 5 m, and potential energy formula we have mgh, because we have to calculate the value of height. Okay, so here h and h cancel out, sorry, m and m cancel out, and here h we got it as 5 by g value is given as 10, so that we got it as 0.5 meter. It means that the simple pendulum who we have given the velocity of 5 meter per second, it raises to a height of 0.5 meter. On its extreme position it goes, and here 60% energy is lost in overcoming the friction, only 40% energy is left. Clear?